All right, let's just jump right into this explainer and decode the absolute massive financial and technological shifts happening in AI and commercial space tech right now. We are currently witnessing an intersection of technology and capital that is quite literally reshaping our world. And, well, frankly, the space around it too. The scale of investment and the speed of advancement we're seeing are completely unparalleled, but it definitely brings some deep complexities and friction along with it. We're dealing with civilizational scale economics here.
To really wrap our heads around the sheer scale of this boom, you just have to look at NVIDIA's staggering Q1 revenue, an $81.6 billion anchor that basically proves we're in a completely new era. I mean, they are putting up 85% year-over-year growth and pulling in $48 billion in free cash flow, all while operating at 75% gross margins. These aren't just good earnings. These are the actual economics funding the next frontier of human engineering.
So here's our quick roadmap for today. We're going to cover the trillion-dollar momentum, the engine room featuring recursive AI, progress versus the workforce, and finally, navigating investor risks. Okay, Section 1, the trillion-dollar momentum. Let's get into it. When we break down SpaceX's staggering $1.75 trillion potential IPO valuation, it splits really cleanly into three distinct units. First, Starlink is the absolute cash cow. It's doing over $11 billion in revenue and pulling in $4.4 billion in operating income. Then you have the traditional space business, which is steady. But that third pillar, AI and compute, is where the really massive bets are being placed. It brought in $3.2 billion in revenue, but operated at a massive $6.4 billion loss. Why? Because they are just aggressively spending on infrastructure right now to build out future capacity. And the main driver behind that huge capital expenditure, it's companies like Anthropic. This leading frontier AI lab actually signed a deal to pay SpaceX $1.25 billion a month just to rent the Colossus compute cluster. That is $15 billion a year for what is essentially becoming Elon Web Services. It's brilliant, really, turning the heavy cost of building data centers into this high-stakes, incredibly lucrative revenue engine for the future. Moving right along to Section 2, the engine room, focusing on recursive AI.
So, the crucial concept you need to grasp for future industry innovation is recursive self-improvement. This is basically the holy grail that experts like Andrej Karpathy, who, by the way, just joined Anthropic, are working so hard to unlock. Instead of just feeding static human data to an AI, recursive self-improvement allows the model to act as its own teacher. When an AI can iteratively train and improve itself while it's actively running, it creates this entirely new kind of Moore's law, pushing model quality up exponentially.
And the crazy part is, we're already seeing this in action. Take Cursor's Composer 2.5 as a great example. First, you deploy the base model. Next, you run recursive reinforcement learning using the system's own native coding data. And then, within literally just 3 or 4 weeks, it achieves Pareto-dominant performance. That basically means it mathematically shatters previous benchmark ceilings. The efficiency gains we're talking about are tremendous, and the speed of learning is only accelerating.
But to actually support this massive demand for compute, you need physical infrastructure. Just look at SpaceX's data center build times. Their first one took 122 days. The second one, down to 91 days. And the third took just 66 days. They are stamping out these gigawatt-scale data centers at a speed and cost that is practically unheard of in the industry. They're just aggressively stripping away all the physical bottlenecks to AI scaling.
Now, looking a bit further ahead, the ultimate unbottlenecked solution might actually be orbital compute. No, really, there is a serious push right now to put working GPUs into space to avoid Earth's power grid and energy limitations entirely. With heavy-lift rockets like Starship designed for rapid reusability, placing data centers in space by 2030 is shifting from total sci-fi into a very real, awe-inspiring strategic objective for these major tech firms.
All right. Section 3, progress versus the workforce.
As we pivot to the human element, there's a profound tension currently tearing through the corporate world. On one side, you have executives chasing unprecedented margins by automating cognitive tasks and totally thinning out middle management. But on the flip side, the workforce is dealing with sudden obsolescence, serious job insecurity, and this looming fear that their daily work is simply being recorded to train their automated replacements. And the messaging around this from the top? It's been incredibly blunt. Take Cloudflare's CEO, Matthew Prince, for instance. He actually stated in a public memo that he laid off over 20% of his workforce.
Not because the company was struggling, but to get rid of middle management measurers, who he deemed, quote, unnecessary because of AI. Mark Zuckerberg highlighted a similar strategy, and honestly, it strikes fear into the heart of a lot of engineers. He explicitly noted the value of using their current, highly intelligent workforce to solve tasks and build tools that teach the AI models how to code. It creates this dynamic where workers feel like they are just keeping their jobs long enough to literally train their own replacements. Naturally, as an explainer of this situation, I have to point out that this messaging is creating a massive public relations challenge for the entire tech industry. When the architects of this technology openly discuss the obsolescence of the human worker in such clinical, matter-of-fact terms, it sparks an immediate backlash. It's creating a deep psychological current of anti-technology sentiment that the industry is really struggling to navigate right now. Finally, Section 4, Navigating Investor Risks. Because despite all these utopian AI visions, investors are facing some very stark macroeconomic realities. We are looking at sticky inflation, with some forecasts actually projecting CPI moving back towards 6%. 10-year U.S. Treasury yields have hit 4.6%, and globally, bond yields are surging. Add to that the severe geopolitical threats to energy supply chains, which, remember, directly dictate the cost of the electricity needed to run these massive AI models.
And to really underline this macroeconomic reality, global debt to GDP is currently sitting at an astronomical 310%. That is wild. The spending required to keep economies growing and to support existing leverage at federal, state, and local levels creates this massive, precarious weight on the entire global economy. So ultimately, investors have to strictly weigh two entirely different paradigms against each other. The tech bull case points to undeniable AI breakthroughs, unprecedented corporate cash flow, and domestic energy independence that fuels all this infrastructure. Meanwhile, the macro bear case points to ballooning global debt, sticky inflation, and a high interest rate environment that threatens to act like gravity on these trillion-dollar valuations. It's a real tug of war. So I'm going to leave you with this final thought to take away from our explainer today. Will the incredible technological abundance generated by recursive AI and next-generation space infrastructure be enough to outweigh the very real human, societal, and economic friction it's leaving in its wake? It is absolutely the defining question of our era, and the answer is going to shape the decades to come. Thank you so much for joining me.